Hello everyone. In this tutorial, we are going to explain time division multiplexing. So, have you ever wondered how thousands of people make a phone calls and communicate at the same time? Yet, there are only 4 wires on each telephone pole that accommodate all these calls. We all know that there is one wire to our house and one to the house of the person we want to call. But how is it possible that our lines and the lines of every other person living in our neighborhood all send the information through only one common line, and furthermore, how is everyone's information received simultaneously or at the other end? The answer behind this is a simple concept called as time division multiplexing. Although modern telecommunication networks use much faster and more efficient methods, that is time division multiplexing, in short TDM, for important communication techniques in the older days and can still be used effectively for small networks. So this tutorial is going to take you through the main concept involved in the TDM. So in TDM, the multiple signals are transmitted in a different time slots. Each signal can occupy the entire bandwidth of the channel. However, each signal is transmitted for only short interval of time. So whatever the signals are transmitted in the TDM, that are transmit turn by turn method. So for example, if there are 3 signals are transmitted over a single channel, so each signal is allowed to use the channel for a fixed period of time, one after the another. So once all the signals have been transmitted, the cycle repeats again and again. So equal time slots are given for each signal. So signal transmission of each signal completes one operation which is called as a frame. Suppose we want to transmit 3 messages like A, B and C coming from 3 different users. So the message A is transmitted first, followed in time by message B and then message C. So in this technique, all the 3 messages are divided into the small parts called as packets. And these packets are of equal lengths. So these packets constitute the messages, that is A, B and C are interleaved and assigned different time slots, and then they are transmitted one by one. So this is the basic concept of the TDM. Now we are going to discuss the practical demonstration of TDM. So to design this time division multiplexing circuit, here we are going to use 555 IC. So 555 IC, it is used for timer, used as a timer. So here we are using 3 555 IC, each having two resistors and two capacitors along with along with each 555 IC. So it is basically used to calculate the time corresponding by each IC. So after getting the time from each 555 IC, all are connected to the multiplexer circuitry. So here we are using 2:1 multiplexer for generating the time interval. So whatever the time is to be calculated, according to that time, we are going to calculate its frequency. So each 555 IC will generate the different frequencies. So we'll calculate all these frequencies coming from this 3 IC. So first 555 IC will generate some frequency, we'll call as a, for example, F0. Second 555 IC will generate the some frequency which is considered as F1. Third 555 IC will generate the frequency as F2. So all these signals are connected to this multiplexer circuitry. So we know that multiplexer will take that data, multiple inputs connected together, and according to that multiple inputs, it will select the only one data, and that data will pass at the output. So the frequency corresponding to this, it is calculated with the help of the formula as 1.44 divided by Ra plus twice Rb into C. So with the help of this table, we'll get the calculated frequencies from each 555 IC. So to calculate the frequency, we require the value of Ra, Rb and C. Once we'll get this frequency, we can calculate the frequency for all these 555 IC. Once we'll get the frequency, we'll measure the frequency on a CRO. So here let's see how that frequencies are to be generated, This is the practical demonstration of time division multiplexing. Here we are connecting the CRO positive probe towards the each 555 IC, likewise F2, F1 and F0 frequencies. So here see, here we are connected probe of the CRO towards the F1 frequency. So the F1 frequency will see in the CRO, it will getting like this output. Now we are connecting the CRO probe to the F2. See what type of output is to be generated. So once we are connecting the CRO probe to this F2 frequency, we'll get this type of output. Now we are connecting the CRO probe to the F0. It will get the oscillatory. Okay. So now the final response coming from this time division multiplexing, all these three outputs are combined together, it will form a the final response like this. Please check this response. This is the final output coming from this time division multiplexing. Thank you.